Welcome to the Victory Education Lounge. I am your host Maurice, and we're thrilled to have you join us for another exciting episode. Before we dive in, please like, subscribe, and leave a comment below sharing your thoughts or experiences. Your engagement helps us create more valuable content and builds a community dedicated to advancing health knowledge. Today we're exploring part 142 of our series, Future Directions in Insulin Resistance Research. As our understanding of insulin resistance continues to evolve, researchers are opening up new frontiers in diagnosis, treatment, and prevention. Let's delve into some of the most promising areas of future research. Ever wondered how the future of insulin resistance research might look like? Well, you're in the right place to quench your curiosity. Welcome to part 142 of our series, Future Directions in Insulin Resistance Research. We are navigating through the exciting realm of medical science, where new discoveries are made every day. Our focus today is insulin resistance, a condition with far-reaching implications for various health disorders, especially diabetes. It's a complex puzzle researchers worldwide are tirelessly working to solve. As we venture forward, we'll uncover how our understanding of insulin resistance is evolving, and how researchers are opening up new frontiers in diagnosis, treatment, and prevention. From gut microbiome modulation to chronotherapy, from nanotechnology-based treatments to brown fat activation, and even Senolytic Therapies, there's a lot to look forward to in this episode. So, buckle up your science seatbelts and stay tuned as we explore some of the most promising areas of future insulin resistance research. One exciting direction is the study of gut microbiome modulation. This fascinating field of research revolves around the idea of altering our gut microbiome, the vast community of microorganisms that live in our digestive tract, to improve insulin sensitivity. This approach is non-invasive and potentially powerful, as our gut bacteria play a critical role in our overall health, including our metabolism and immune function. But it's not without its challenges. The gut microbiome is highly complex and unique to each individual, which means results could vary greatly from person to person. To give you an idea of the potential in this area, let's consider a study published in the prestigious scientific journal Nature. In this study, researchers conducted fecal microbiota transplants from lean donors to individuals with metabolic syndrome. The results? These individuals experienced increased insulin sensitivity, suggesting that a healthier gut microbiome could indeed play a significant role in managing insulin resistance. However, it's important to remember that we're just at the starting line in this race. There's still a lot we don't know about the gut microbiome, how to best modify it, and how these modifications might affect people differently. But one thing's for sure, this research could open up new ways to improve insulin sensitivity. As we continue to explore the vast universe within our guts, we're likely to uncover more secrets about how our microbiome influences our health, and how we can harness this knowledge to combat insulin resistance. Next, we have the fascinating world of epigenetic therapies. Now, you might be wondering, what exactly are epigenetic therapies? Well, they are treatments that aim to manipulate gene expression to improve insulin sensitivity. And the intriguing part, this is achieved without altering the DNA sequences themselves. Instead, these therapies target the epigenome, the multitude of chemical compounds that can tell the genome what to do. Imagine genes as an orchestra, and the epigenome as the conductor. The conductor doesn't change the instruments but controls how they play together to create a symphony. Similarly, epigenetic therapies don't change the genes but influence how they work together, potentially leading to improved insulin sensitivity. Sounds promising, right? But it's not without its challenges. Epigenetic therapies are still in the early stages of development, and the long-term effects are unknown. Plus, it's a complex process. Each person has a unique epigenetic profile, which means treatments may need to be personalized. Yet, the potential is enormous. A study published in the journal Cell Metabolism demonstrated that certain epigenetic changes could protect against diet-induced obesity and insulin resistance in mice. This finding suggests that if we can learn to control these epigenetic factors, we might be able to offer a new level of personalized treatment for insulin resistance. So, the future of epigenetic therapies is looking bright. These therapies could pave the way for personalized treatments. The third direction is the innovative approach of chronotherapy. This fascinating strategy revolves around timing the delivery of treatments to coincide with the body's natural circadian rhythms. It's like synchronizing your watch with your body's internal clock to maximize the effectiveness of your medication. The potential benefits are quite compelling, but it's not without its challenges. Implementing this approach requires precise timing, which may prove difficult in practice. For instance, let's look at a study published in the journal Diabetes Care. Researchers found that taking metformin, a common drug used to manage type 2 diabetes, at optimal times based on circadian rhythms, improved its glucose-lowering effects. This is a promising discovery that could lead to more effective management of insulin resistance and diabetes. In summary, by aligning treatment with our body's biological rhythms, chronotherapy could enhance the effectiveness of existing treatments. As we continue to refine this approach, it could become a standard part of insulin resistance management in the future. The fourth direction is the cutting-edge field of nanotechnology-based treatments. Nanotechnology, the manipulation of matter on an atomic, molecular, and supramolecular scale, is being harnessed to tackle insulin resistance in novel ways. Researchers are developing nanoparticles that could deliver insulin more effectively or target insulin-resistant cells specifically. This could potentially offer more precise and effective treatments for insulin resistance. However, the use of nanotechnology in healthcare is not without its challenges. The technology is still in its nascent stages of development, and there are valid concerns about the safety and long-term effects of these microscopic particles in the human body. Rigorous testing and trials are necessary to ensure these treatments are safe and effective. One promising application of nanotechnology is the development of smart insulin patches. These patches, developed by scientists at North Carolina State University, use nanoparticles to regulate blood sugar levels. The patch is designed to release insulin into the bloodstream when it detects a rise in blood sugar levels. This could potentially offer a more streamlined and responsive method of insulin delivery, reducing the risk of hypoglycemia and improving the quality of life for people with diabetes. Despite the challenges, the potential of nanotechnology in the treatment of insulin resistance is immense. With further research and refinement, nanotechnology could revolutionize insulin delivery. Fifth, there's the intriguing research into brown fat activation. Now, you might be wondering, what's brown fat? Well, unlike white fat, which stores energy, brown fat burns it. It's named for its rich supply of blood vessels and mitochondria, which give it a brownish color. When brown fat is activated, it generates heat and burns calories, which could potentially help with weight management. But it's not just about weight. Brown fat activation could also improve metabolic health and insulin sensitivity. You see, when brown fat burns energy, it uses glucose and fats from the bloodstream, which could help regulate blood sugar levels and improve insulin's effectiveness. However, there are challenges. The methods for safely and effectively activating brown fat in humans are still under investigation. It's a complex process that needs to be fully understood before it can be harnessed for therapeutic purposes. Still, the potential is exciting. For instance, a study published in Nature Medicine showed that a compound called BAM15 could activate brown fat and improve insulin sensitivity in mice. The researchers noted that BAM15 could be a potential therapeutic agent for treating obesity and type 2 diabetes, although more research is needed. In conclusion, activating brown fat could be a game changer for metabolic health. It's an avenue of research that holds a lot of promise, and we're excited to see where it leads. Finally, we have the promising field of Senolytic Therapies. Senolytic Therapies are a cutting-edge frontier in insulin resistance research. These therapies aim to eliminate senescent cells, old cells that have stopped dividing but remain metabolically active. These cells can build up over time and contribute to various age-related diseases, including insulin resistance. The beauty of Senolytic Therapies lies in their potential to address a root cause of metabolic dysfunction, rather than just managing the symptoms. By clearing out these senescent cells, we could improve insulin sensitivity and overall metabolic health. However, every rose has its thorns. The potential challenges for Senolytic Therapies include the risk of side effects, and the fact that the long-term impacts are not yet fully known. As with any new treatment, rigorous testing and clinical trials are needed to ensure safety and efficacy. One example of the exciting research being conducted in this area was published in the prestigious journal Cell Metabolism. The study found that clearing senescent cells improved insulin sensitivity in obese mice. This research represents a significant step forward, but it's important to remember that results in mice don't always translate directly to humans. Despite the challenges, the potential of Senolytic Therapies to revolutionize the way we approach insulin resistance is immense. Senolytic Therapies could address a root cause of metabolic dysfunction. So, Those are 7 exciting directions in insulin resistance research, from the modulation of the gut microbiome to the development of nanotechnology-based treatments. Each approach holds promise for improving our understanding and management of this pervasive health issue. Epigenetic therapies, chronotherapy, brown fat activation, and Senolytic therapies are also reshaping the landscape of insulin resistance research. Thank you for joining us in this journey of discovery. Don't forget to like, subscribe, and share your thoughts in the comments below. As we look to the future, it's clear that our approach to insulin resistance will likely become increasingly sophisticated and personalized. We may see treatments that are tailored not just to the condition, but to each individual's unique genetic makeup, lifestyle, and environment. While we await these exciting developments, it's crucial to remember that many effective strategies for managing insulin resistance are already available. A healthy diet, regular exercise, stress management, and proper sleep continue to be foundational in maintaining metabolic health. Thank you for joining us in the Victory Education Lounge for this exploration of future directions in insulin resistance research. If you found this video helpful, please give it a thumbs up and share it with friends who might benefit from this information. Don't forget to subscribe for more content on health, nutrition, and cutting-edge medical research. Until next time, stay informed, stay healthy, and keep striving for victory in all aspects of your life. Disclaimer. The information provided in this video is for educational and entertainment purposes only. It is not intended as medical advice. Any health-related decision should be discussed with a licensed physician or qualified healthcare professional, especially if you have existing health conditions or are taking medications.